Okay, max and min. I only have one critical number that I have to check here. And looking at my circle here, it's increasing, then decreasing. So I have a max there. So that is part F. So we say local max at x equals 0. And f of 0 we computed earlier. We got negative a quarter. So again, I know it's a max because it's increasing before x equals 0 and decreasing after. That's going to be a max. G, concavity. Concavity, concavity, concavity. So I'm going to need the second derivative, which is right here, 2, 3x squared plus 4. All over x squared minus 4 cubed. So again, I'm not showing my work for these first and second derivatives, just to save time. So let's first of all find out where this is 0. Never. Okay, this numerator is never 0 because this number is positive number plus positive number. You cannot get 0 from that. So I'll write no solution. So on my number line for the concavity, I'm going to have just my asymptotes. Okay, remember, always put your asymptotes on these number lines. And I have no points at which my second derivative is 0, which means I have okay, we'll talk about IPs later. Let me just focus on my number line for now. So we're doing concavity using test points. So plugging in the number over here, so negative 3, what are you going to get? Notice that the numerator is always positive. So I just need to focus on the denominator. So I plug in, say, negative 3, then I'll get 9 minus 4, which is positive, cubed is positive. So positive over positive. So concave up here. If I plug in, say, 0, that's easy. I'm going to get positive over, now it'll be negative, because it'll be a negative 4 cubed downstairs. So concave down here. So I'm just doing test points kind of mentally here. And then finally, if you pick something bigger than 2, say 3, your denominator will be positive and your numerator will be positive as always. So concave up here. Okay, inflection points. So inflection points, these are points at which the function is continuous and the concavity changes. So we have a concavity change here and also here, but minus 2 and 2 are asymptotes. The function is not continuous there. So we have no inflection points. Again, it's because, sure, concavity changes here and here, but for an inflection point, we need the function to be continuous. Okay, now we're ready to draw here. Now, what I usually do is I start with the points I have. The only point I have, I think, is this one here. X is 0, y is negative a quarter. So I'll start with that. Perhaps before I get in there, I'll do my asymptotes. Oops. Choose a scale here, minus 2 here. 2 here, those are my asymptotes. So we have the point 0, negative a quarter. So if this is -2, that would be -1. Negative a quarter would be roughly here, right there for my point there. Okay, that's tough, only 1 point. But the asymptotes, put the asymptotes in, vertical. And then recall your number lines here. You have some number lines here. It was -2, 0, and 2 for the increasing, decreasing. And what was it? It was increasing, and then increasing again, then decreasing, decreasing. And then for my concavity, I had just -2 and 2. And it was concave up, concave down, concave up. Okay, so I should be able to connect the dots from here and figure out what's happening. Let's start at this guy. We determined earlier that this is a max. Got a max there. Okay, so that's a max. So I'll put a little hill there. And then what's happening from that hill? Well, the function should be increase, looking at this arrow here, the function should be increasing here, then it should be decreasing here. And I have asymptotes. So how can that work? Well, there's really only one possibility. It's got to be going like this, approaching my green dotted line. And similarly over here, it's got to be going like that, right? There's no other way for this to satisfy that arrow there and that arrow there. Okay, it should be concave down between -2 and 2, but that's the way I've drawn it here, right? The cup is facing down. Okay, how about this region over here? So it should be increasing, and it should be concave up. Now let's remember what my function is. Now it's going to be useful for me to see that if I have x smaller than -2, then this is positive. Okay, so my function exists up here. Now we saw before that it has an asymptote to respect, so it's got to be going up like this, right? Got that vertical asymptote. And you also have a horizontal asymptote. So asymptotes help me, and I know it's positive. So I know it's up here, not down here. So I can see only one possibility. You just connect the dots like so. And there you go. Now over here, we have it's decreasing and concave up. If I look at the function, I can determine that it's actually going to be up here and not down here, because if x is bigger than 2, then my function is positive. So the function is happening up here. And we found earlier that I have this asymptote to respect here. And down here I also have an asymptote to respect, so I'll draw a little arrow like that. And there's really no possibility here except to connect the dots like so. Okay, this looks good to me. The last thing you want to do is just double check that the drawing you've made does indeed respect especially these two number lines.